quite customized. So I will explain why would you do that and how would you do that. And everything which I will be speaking about up until this point has already been done and released, so you can use it. But there is some room for improvement, and this is what I will be touching in the future section. So first thing first, ViRT V2V. How many of you know what ViRT V2V is? Quite a lot of guys. Okay, not everyone. So just quickly, it's a command line tool. It can read foreign hypervisors. It can read couple, but for the sake of this talk, only the VMware is the interesting one. It can optimize and convert the guest in a way that it will be then running on KVM. So what it actually does is something like this. So on the left-hand side, you can see the source, which is the VMware. On the right-hand side, there is some storage domain, which can be some iSCSI or NFS or whatever, where the converted disks will go. And in the middle, there is some Linux box with ViRT V2V installed. In this case, it happens to be an oVirt hypervisor, but it doesn't has to be. So when ViRT V2V is asked to convert some virtual machine, first thing it does, that it asks the VMware API using libvirt about the metadata of the virtual machine. Based on this, the metadata, it creates thin overlay images for the disks of this virtual machine. These are just thin overlays, so they need some backing. So the backing is set to the actual disks which are still on the VMware side. Now it needs to access the guest file system of those images to do some modifications inside them. For this, it boots up a temporal virtual machine. It is not the virtual machine we are converting yet. It is just some virtual machine used to access the guest file system. Boots it up, attaches the image, and runs some modification inside. So what modification it runs depends heavily on what is installed on that image actually. For example, if it is a Windows, then it copies the virtual drivers on that image, on that file system, and modifies the Windows in a way that on the first boot it will actually install those drivers. When the image is guest is prepared and optimized and everything, then it's time to actually copy the disks. So image convert is called for this, and it actually starts copying the disk from VMware over to the output storage, and on the way it converts it to QCOW, which is the native format for the KVM. So with this, the role of the ViRT V2V from this process ends. And next step up is the oVirt. So how many of you guys know what oVirt is? Cool. That's my homeland. It's a traditional virtualization solution. It manages the virtual machines as well as the storages and networks for them. And in this process, it is the target to which we are converting the virtual machine. This is how it looks like. So it has an engine, something we call an engine. It is a centralized service which contains all the business logic and exposes an API and some front end. It divides the resources into data centers, which are data centers, which are then more cut up to clusters of hypervisors. And in these hypervisors, which are some Linux boxes, which are services, it runs the virtual machines. So how this fits into the picture of this ViRT V2V? So every oVirt hypervisor comes with the ViRT V2V reinstalled. So when oVirt decides to migrate some virtual machine to one of its clusters, it just picks a random hypervisor in that cluster and uses it as a migration host. This is how. So the bottom part of the image is simplified version of the image I have shown before. It's an oVirt hypervisor, the source VMware, and the output storage, which is managed by oVirt. Above that, you see the oVirt engine, which is that centralized logic, and its database, where the metadata are stored. So oVirt, in order to have a virtual machine it can manage, it needs two things. It needs the metadata, and it needs the disks of it.
So first thing first, it takes the metadata. So it picks a random hypervisor, and the same way as virt v2v does, oVirt talks to the VMware API using libvirt to get the metadata of the virtual machine. Converts them into his own native format, puts them to the database. Now it has the metadata. After this, it needs the disks. Again, picks a random hypervisor and contacts the virt v2v on it and calls the command line that to convert the disks of that VMware VM and put the disks over there. When it's done, oVirt has the metadata, has the disks, so it's happy and it can manage the virtual machine. The story ends for oVirt in this stage. So the last component in this story is the ManageIQ. So how many of you guys know what ManageIQ is? Oh, it goes down. Everyone knew virt v2v. And anyway, so ManageIQ is the manager of the managers. It is a cloud management platform, which means that it provides some centralized management logic for lots of different services like clouds and virtualizations and so on. So what it actually does is that at the bottom of the image, you see some gray boxes. I will call them here third-party services, because I like that term. It can be, for example, the whole oVirt is such a third-party service, or the whole VMware, or whole OpenStack, or OpenShift, or whatever, lots of different services. Now, ManageIQ can talk to all of these APIs, understands all of those APIs, takes all the data from all of those third-party services, and stores them in his own unified form in his own database. So now it has a giant database where it has a holistic view of lots of environments and provides different services on top of them. Like, I'm not going to go over all of them. You can feel free to check them out later. I will mention only two, which are important from our perspective, or from the perspective of this talk. One is the UI. So you have one unified user experience over completely different third-party services, let's say. And second is Automate. It's called Automate. What it actually is, to put it simply, it is a way how to write plugins into ManageIQ, but those plugins don't only expose their functionality to the user, but also the implementation. So the user is free to go ahead to the UI, which is used to manage everything, and just modify those plugins and do whatever he wants. So this is what we used. In ManageIQ, this Automate provides both the front end and the back end for these plugins. And the back end is organized as a state machine. So you implement the states of the state machine and also the state transitions, so how the state machine is going to work. So this is what we used. This is how it ended up. So this is a screenshot from ManageIQ of the VMware provider. So you go to the VMware VM, and its lifecycle menu, there is a new button that transfers this VM to ref. Ref is a downstream name for oVirt. Doesn't really matter. If you click that button, you will have a new dialog, which looks like this. It has just a couple of fields. You pick how the virtual machine will be called on the destination, which exact oVirt you want to use, because in one ManageIQ you can have many oVirts, so you say that which oVirt you want to migrate your virtual machine to, which cluster inside that oVirt, which storage, if the disk should be thin provisioned or not, and if it's a Windows virtual machine, then where the drivers are, the virtual drivers are. If you submit this dialog, this is what happens. So the bottom of the picture is the oVirt API. So this is the gateway to the oVirt engine I was talking about. Above that, like in the top part of the picture, you have the core some core components of ManageIQ. The database is the giant database I was talking about before. So it contains all the data from everything. And there is some component. For the sake of simplicity, I call it here refresher. It is something which makes sure that the database is always up to date. In between, there is the promise state machine. So when you submit a dialog, the first state which takes over is the launch. The launch state, basically what it does, it just takes all the data from the dialog I filled in, composes a REST API call,
and sends it over to oVirt's REST API. Then oVirt starts doing all of its magic, like taking the metadata, contacting virt v2v to start copying the disks and so on. This takes time. So the next stage here is just waiting. This state wakes up every 3 minutes, checks the database. It doesn't check the oVirt API though, it checks its own database. While the refresher makes sure it's up to date. And waits until, well, the migration actually finished. When it's finished, the last state in this state machine is the configure networks. This is a post-migration state, which means that at this point, the virtual machine is already in oVirt successfully. It has the metadata, it has the disks. You can start it, you can use it, but it doesn't have networking set. Because oVirt takes care also of the virtual network of the virtual machine. So what is needed here is to, what this state does is it looks at the virtual machine, checks what network interfaces this virtual machine does have, and plugs a virtual network, oVirt virtual network, into each of the network interfaces. And this is pretty much it. This is what is done by default. And this, let's say, works for the typical case. But as we all know, the typical cases are very rare. So everyone needs to do some customization, something special somewhere. Especially if you are talking about pet virtual machines, which is oVirt is for pet virtual machines, then you need to do something special all the time. So for example, just at least, I don't know, send an email that you will have an outage. Or run some Ansible script in the source before it's migrated to prepare it for being moved to some other place. Or, I don't know, after successful migration, rename the source VM to something like migrated, but whatever. And these are all things which we cannot really anticipate. And this is why we have used the automate to implement this migration logic. And this is how you can modify it. So as I said, the automate scripts, not only the UI and functionality is exposed to the user, but also the implementation. So this is a straight screenshot from the ManageIQ UI, where you can see how this state machine I was just talking about looks like. It has the 3 states I was mentioning: the launch, wait for import, and configure networks. You can go ahead and add your own states in between, before, after, wherever you want, and implement the content of the state as you wish. You can implement whatever you want there. If you need something special in the UI, this is again a straight screenshot from the ManageIQ UI, where you have a dialog editor. So you can go to this UI, you can edit this dialog, and you can add your own specific widgets you need. And of course, implement the logic behind. So this is what we have done. This is all released and working. So if you now go ahead and install the latest releases of all these components, you can use it. But there is some room for improvement, and I have divided it into 2, the high and the low level. We'll start with the high level, which is in this case the ManageIQ. So as you remember, in ManageIQ, I picked one particular VM and told it, go ahead and migrate it over there. This is good if you have a couple of VMs you want to migrate. It's not so great if you have a couple of thousands of VMs you want to migrate. It would be much better to have some abstract entity. I call it here migration group. You can call it however you like, which just is some bucket of virtual machines you want to migrate in one group, ideally in batches. But when you're migrating this bunch of VMs together, you don't necessarily want to migrate all of them to one cluster in oVirt, or you don't always want to channel all the disks of all the virtual machines to one storage on the oVirt side. So what you want to do instead is to do some kind of resource mapping. So you say that all the virtual machines in this cluster in VMware should go to that cluster in oVirt, and all the VMs from all the storage, all the disks on the source VMware there has to go to that storage on the destination. So you have these 2 abstract entities. You join them together, and then you have some actual migration, or how to call it, something you can submit to the ManageIQ infrastructure, and it then takes care of, for example, migrating them in batches during some migration windows, something like that. That would be pretty cool to have. From the low-level perspective, one thing, oVirt now uses Virt v2v as is. So it is really using the command line interface of the Virt v2v. And Virt v2v is installed on every hypervisor of the oVirt. So oVirt is pretty much now acting as a mediator between ManageIQ and Virt v2v. It would be so much better if we or someone would contribute into Virt v2v itself, or to some scripts around, doesn't really matter, the knowledge of the oVirt's API. So the oVirt would suddenly be passive in this role. It will be only the receiver of the incoming data, and Virt v2v would use the oVirt's upload API to upload the disks, use the normal API of oVirt to create the metadata and connect everything together. This has a couple of advantages. One, less work for oVirt. Simpler code and everything. Second, you don't necessarily want to have the logic of migration, not just logic, but the load of the migration on a hypervisor you are using for the core virtualization. And third, possibly the most important, then you could reuse the same logic or very similar logic to migrate to something else, for example, to OpenStack. So this is, let's say, the one. And the second enhancement on these lower layers is that currently, when the disks of the virtual machines are copied over from VMware to oVirt, then HTTP is used as a protocol to get the VMs from VMware, which is not ideal. Virt v2v supports also better ones, SSH and VDDK. VDDK is a proprietary tool from VMware, which are both much faster, and between each other they have advantages and disadvantages. We just need to figure out which one do we want to use and how to integrate it in a good way so it will be easy to use for the user. So this pretty much concludes also the low-level future plans. The important point here is that these are not some wishful thinking, so the next slide is not going to be that patches will come, but we are really working on these items now, and then should arrive in one of the upcoming releases. So thank you, and if you have any questions, please ask. Yeah.
Is there some work on converting not just the VM themselves, but the kind of setup of VMware?
During the storages and everything?
Storage setup, network setup.
Yeah, so the question was if there is some work being done on not only the virtual machines conversion, but also on all the infrastructure that VMware is providing. So short answer, no. No, we are expecting the user to configure oVirt, to configure all the resources around, and then just to migrate the virtual machines into there. Okay, so if there are no other questions, I'm not going to be standing here for 5 minutes, but you will find me at the oVirt booth, which is somewhere next to the main entrance, or not only me, but anyone else from the oVirt team will be more than happy to discuss this topic. Thank you for your time.